ASME Section VIII Division 1 Introduction to Pressure Vessel Design. Hello everyone, welcome to this session. My name is Arun Kumar Srivastava and today we will discuss an introduction to ASME Section VIII Division 1, which is one of the most widely used codes for pressure vessel design and fabrication in the world. This session is a part of the 5 days online training program conducted by URGS International Engineering Services Private Limited. We provide 5 days online training. So this is just a course overview. So in this video we will cover overview of the ASME boiler and pressure vessel code, scope of section 8 division 1, basic design philosophy, cell design basics, heads used in pressure vessels, nozzle openings and reinforcement, basic design considerations. By the end of this session, you will understand how engineers start designing pressure vessels according to ASME code. Second, what is ASME BPVC? The ASME boiler and pressure vessel code commonly called ASME BPVC is a globally recognized standard used for the design, fabrication, inspection, testing and certification of pressure vessels and boilers. ASME stands for the American Society of Mechanical Engineers. This code ensures that pressure vessels are designed and manufactured safely. The ASME code is divided into several sections such as Section 1 Power Boilers, Section 2 Materials, Section 5 Non-Destructive Examinations, Section 8 Pressure Vessels, Section 9 Welding Qualifications. Our focus today is Section 8, specifically Division 1, which provides design rules for pressure vessels operating above 15 psi. Scope of Section 8 Division 1. Section 8 Division 1 covers the design and construction of pressure vessels. Pressure vessels are widely used in industries such as oil and gas, petrochemical plants, power plants, chemical processing industries, refineries. Examples of pressure vessels include reactors, heat exchangers, storage tanks, separators, air receivers. Division 1 provides simplified design rules which makes it the most commonly used division. There are also other divisions. Division 2 Alternative rules with higher stress values. Division 3 High pressure vessels. Most industrial pressure vessels are designed using Division 1 rules. Now basic components of a pressure vessel. A typical pressure vessel consists of several main components. First is the cylindrical cell. The cell forms the main body of the pressure vessel and contains the internal pressure. Next are the heads. Heads close the ends of the cylindrical cell. Common head types include elliptical heads, hemispherical heads, torus spherical heads, flat heads. Another important component is the nozzle. Nozzles are opening in the vessel used for inlet connections, outlet connections, instrumentation, safety valves. Other components include flanges, supports, manholes. Each component must be designed according to ASME code requirements. Next is design pressure and temperature. One of the first steps in the pressure vessel design is determining the design pressure and design temperature. Design pressure is usually higher than operating pressure to provide a safety margin. For example, operating pressure equal to 8 bar, design pressure equal to 10 bar. Design temperature is also important because material strength changes with temperature. The ASME code provides allowable stress values for materials at different temperatures. These values are available in ASME Section 2 Part D. Cylindrical cell design. Now let us look at cylindrical cell thickness calculation. According to ASME Section 8 Division 1, the required thickness for a cylindrical cell under internal pressure can be calculated using the formula T equal to P into R upon S into E minus 0.6P. Where T equal to required thickness, P equal to internal design pressure, R equal to internal radius, S equal to allowable stress of material, E equal to weld joint efficiency. Joint efficiency depends on the type of weld and inspection level. For example, for fully radiographed welds have higher efficiency. Partial inspection have lower efficiency. After calculating the required thickness, we must also consider corrosion avoidance manufacturing tolerance. Then next is heads used in pressure vessels. Pressure vessels use different types of heads depending on design requirements. Elliptical heads are the most common type used in industry. They provide a good balance between strength and cost. Hemispherical heads are very strong because stress is evenly distributed. However, they are expensive to manufacture. Tawny spherical heads are cheaper but may require thicker material due to higher stress concentration. ASME codes provide separate formulas for calculating the thickness of each head type. Then next is openings and reinforcement. Pressure vessels require openings for nozzles and manholes. However, cutting an opening in a pressure vessel weakens the cell. To compensate for this loss of strength, reinforcement must be provided. Reinforcement can be provided by extra cell thickness, reinforcement pads, nozzle neck thickness. ASME code specifies that the area removed by the opening must be replaced by reinforcement area. This ensures the vessel maintains its structural integrity. The next is inspection and testing. Before a pressure vessel can be used, it must pass several inspections and tests. These include non-destructive examinations such as radiographic testing, ultrasonic testing, magnetic particle testing. Another important test is the hydrostatic pressure test. During this test, the vessel is filled with water and pressurized to about 1.3 times the design pressure. This verifies that the vessel can safely withstand operating pressure. To summarize today's session, we discussed Introduction to ASME BPVC, Scope of Section 8 Division 1, Components of Pressure Vessels, Design Pressure and Temperature, Cell Thickness Calculation, Head Types, Nozzle Reinforcement, Inspection and Testing. Understanding these fundamentals is essential for pressure vessel design engineers. If you are interested in learning the complete design calculations, case studies, and practical examples, you can join our 5-day online training program on ASME Section 8 Division 1, conducted by URGS International Engineering Services Private Limited. Our email ID is info@urgseng.com. Mobile/WhatsApp number is +91 7359458455. You can contact us for training registration, course schedule, corporate training programs, engineering consultancy services. Thank you very much for watching this session. If you found this video useful, please like, share and subscribe to the channel for more engineering training content. See you in the next session. Thank you.